Okay, good afternoon, everybody. Thank you for being here. Let me start with the required territorial acknowledgement. The University of Waterloo acknowledges that much of our work takes place on the traditional territory of the Anishinaabe people and Haudenosaunee people. Sorry about that. Our main campus is situated on the Haldimar Track. The land granted to the Six Nations that includes 6 miles of each side of the Grand River. Our active work towards reconciliation takes place across our campuses through research, learning, teaching, and community building, and is centralized within the Office of Indigenous Relations. It is my pleasure to introduce our speaker today, Klaus Dorning. Is the founder and president of Green Sun Rising since January 2008. In his previous assignments, he was holding a global research, leadership position in a 500 million Tier 2 automobile supplier group with complete responsibility for P&L, operations, marketing, sales, research, development, supply chain management, finances, and was responsible for an employee base of 4,400 people. So quite a bit of experience in that area. He has 2 master's degrees in mechanical engineering, one from the University of Braunschweig, hopefully I pronounced it correctly, in Germany, and a second master's of applied science at UBC. For over 16 years now, he has built up the local solar activities and expertise, supported and backed by leading European solar companies, with decades of solar experience and know-how. The Renewable Energy Technology Center in Windsor, which I guess we're seeing on the picture here, was founded following his vision. He has over 500 solar projects successfully implemented in Canada to date, and in fact, we're working with him on trying to deploy a solar carport here at Waterloo. Wise is working on that with him. And he's been the project manager and team leader for these projects. 10 years ago, he and Green Sun Rising started to reach out to the northern and remote communities, where energy supply is a challenge. Today, he has implemented 55 solar systems in remote diesel communities. So with that, let me welcome Klaus to our presentation, which will focus on diesel reduction with solar PV in the north, in which Wise is particularly interested in, myself included. Klaus?
Thank you, Claudio. And thank you to the people who have organized this event. I also want to express my appreciation for the work that the WISE Institute does do. It is very important work. About 40 years ago, I was sitting on your side of the table. I was an international student in Canada, and basically, I received mentorship. I was very, very grateful to receiving mentorship as a young student, and so I'm today in a position in my life where I'm giving back, okay? So I'm here to provide you with information and food for thought. 2050, when we want to be completely decarbonized, seems like an awful long time down the road. In reality, as you graduate, you will be successful, professionally employed for approximately 40 years. So that goes way beyond 2050. So you should have a time frame in mind that does include complete decarbonization, okay? So I wanted to just create this framework, or this frame. So I will briefly introduce the team of Green Sun Rising and what we do. This being a technical audience, I have to talk about the principles of solar thermal and the principles of solar photovoltaic. I will not go very deep in the presentation into the photovoltaic effect, but if as part of the question and answer, one of you wants me to go on my 2-minute spiel to explain to you the fundamentals of photovoltaic, I'll be happy to do that. I will then take us north. Canada is the 2nd largest country by land mass, And we have approximately 250 communities up there that are so far away, so remote, that they are not connected to a central grid. They basically operate on diesel in some of the most harsh climate conditions you can imagine. And we work up there. And I will show you examples. I will share data of the northernmost solar system in North America in the northernmost community of North America. And I will highlight a few things on that. I will then share about the largest solar system 3 years ago done, the first commercial independent power producer project we realized in Rankin Inlet. And I will show some cumulative savings of diesel. And there is an 8-minute video that I would like to share. It's called The Smiling Sun. And so that's done about work we did in Nunavut, not Nunavut, in Nain, which is part of the Nunatsiavut community. And then I hope for lively question and answer. That's my expectation to you, lively question and a good discussion. So Green Sun Rising, we were founded in January 2008. So that's 16 years ago, well before the Ontario Green Energy Act, and following principles of my German compatriots, which were already embracing solar energy at the time. So we started with a solar energy focus at a time when no solar energy industry did exist in Canada. In my first year of developing the company, I went to Germany 5 times, and I knocked on the doors of technology leaders. I had the advantage that I came from a senior executive background, and I had a lot of experience, which gave me a standing, and I was completely self-financed. No bank would have financed me because the industry didn't exist in Canada. And I had the advantage of having worked many years and managed my affairs well. So I was able to start the company completely self-financed. But easy, it was not, okay? 11 years ago, we reached out into diesel communities and started to develop a second leg because I felt that the Ontario Green Energy Act, being a political thing, was not reliable enough for the company. We needed a second leg, and I'm very happy we did, because without that, we would not have been able to manage. So solar thermal. We have a solar thermal collector, and these collectors, because they take solar energy and transfer it directly into heat, have a very, very high efficiency, 80%. 80% efficiency on a good solar thermal collector. We use a pressurized closed loop. That means we are not overcoming head. We're only overcoming viscosity. And because we have such a low power pump, I can switch that pump with a controller directly. We have internal heat exchangers. An internal heat exchanger has no external losses. So that means the heat goes where I want it to go, and everything, okay? We have pre-insulated corrugated stainless steel, and my controller function is very simple. I have a temperature sensor in my highest spot in the collector. I have a temperature sensor in my lowest spot in the tank. The controller does a simple delta T. What is my temperature differential? And there needs to be a little bit of a buffer, because otherwise the system is nervous. And then when it recognizes, oh, I have yay much temperature here versus yay much there, it says to the pump, on. That's the whole principle of basically controlling the system. And then the fluid, the working fluid, which is a glycol water mixture, because it does freeze in Canada in winter, I need to frost protect. It simply, by virtue of the pump, is circulating. And now the heat flows automatically from a higher level to a lower level, never the other way around. This universe would explode if heat would flow from the lower to the higher level, okay? So heat always goes from higher to lower. Heat transfer is just beautiful because it happens automatically. So that's the basic of a solar thermal system, totally scalable. A 2-collector system, as shown here, can meet over half of the annual energy needs for domestic hot water for the average family of 4. Solar thermal residential is mandatory by code in Germany. Why Canada is not embracing solar thermal much more is beyond my comprehension. I do solidly believe in the advantages of solar thermal, period. Here's an example of a system we provided into Quebec. Why this steep angle? Winter biased. In winter, the sun is lower on the horizon than in summer. In summer, it's higher, right? I can use the angle as a design tool. And here, I want more building winter heat, so I bias it towards winter. There is another trick I have. The sun rises in the east and sets in the west, right? We have one full turn of 360 degrees in 24 hours, right? That means in 1 hour, the sun moves by 15 degrees. If I bias my solar system towards the east by 15 degrees, I'm shifting my peak exposure by 1 hour. This is a design tool. I can do east-west, I can do east, south, and west, okay? I can use my orientation as a design tool, both in terms of against the sun position, against the horizon, and morning and evening. I have a solar thermal system at my showroom, and I know I have most visitors in the afternoon. What did sneaky Klaus do? I biased my system to the west. So my system is best performing when I have visitors in the showroom, okay? My point to you is, you're engineers, you can use angle and orientation as a select design tool. Think about it. Here is the tank in our showroom. Tank, solar station, controller. You do need an expansion tank because your working fluid is warming up and cooling down, so you do need to have an expansion tank. Perfectly scalable. There is a guy in Switzerland, I have not met him yet, but I would love to. Heat is fundamentally very simple to store. Give me a thermal mass, give me a means of heat exchange, and then I look at what does my medium do. I like water. Water is very common, and we know water freezes below 0 and evaporates, is in a steam regime above 100, so I can basically calculate what I can put in there. And I can do that at any scale. What you see here is a big tank being put in, and you see the building is actually being built around the tank, and then the roof is a complete solar array. This building meets 100% of its heat energy needs from solar thermal with this big tank. Think about it. In remote communities, I'll show you pictures, we have massive fuel tanks. This is a solar energy tank. Once you've got that in place, your only cost is the electricity to run some pumps. Everything else comes in. I personally, years ago, have been to a solar tank like this, 3 stories high. And here's one more thing that happens. Inside that tank is stratification. You put flanges along different heights, temperature sensors along different heights, and now you can pull the heat temperature at exactly the temperature you want because you have stratification. I saw 60 degrees Celsius stratification in that very tank. Technically, very feasible, fundamentally, very simple. Why we don't do a lot of that, I don't comprehend, but it will come. There is actually a system in Alberta, Drake Landing, and they meet all of their building heat energy needs from solar thermal. This is an old image because they don't do borehole. They actually have a large underground concrete bowl, basically, filled with water, and they can harvest solar thermal energy, spring, summer, fall, and then feed the buildings throughout the whole winter with a district heating system. So can be done, has been done. Why this is not being done much more, I don't know. But these are examples of solar thermal. Now we're coming to photovoltaic. Photovoltaic is a completely different animal. Now we need to take that sun energy, those photons, and convert it to free electrons. This is more complicated to do, so my peak efficiency today is at around 20%. Now, if you are saying, oh, what's such a low number? Well, the diesel generator is at 30%. Your best natural gas power plant here in Ontario is peak 40%, okay? So now my 20% doesn't look so bad anymore, does it? And quite frankly, my sun energy comes in free of charge and extremely reliable. So sun energy reaching the solar modules, converted into free electrons in direct current, DC, okay? Solar electricity is DC. We live in an AC world, so I need a unit called an inverter. It's a gray box, full of electronics, by the way. So that inverter turns the solar DC electricity into grid quality AC, okay? When I say grid quality, I need to underline that several times. We have alternating current. That means at 60 hertz, we have 120 zero crossings every second. If you have a sinusoidal function and you superimpose a second sinusoidal curve on it, if you are not completely in phase, you're getting dirty power. So being 100% in phase is absolutely critical. The solar inverter senses the grid, checks the grid for stability, also is looking at over voltage, under voltage, frequency shift, and only when the inverter finds the grid clean for 5 minutes will it connect, and it will feed in perfectly in phase. We call that power factor 1. It follows the grid. A grid interactive connector does not make its own phase. It senses a phase and follows. This is fundamentally different from off-grid, because if you do off-grid, there is no phase to sense and follow, so you need to make your own phase, and you also need to set your own voltage, okay? These are completely different animals. Your most cost-effective is grid interactive. We do what is called net metering, and that means we are feeding the clean solar power on the inside of the load. This also means, because this is now grid quality power, it has no memory. It doesn't know where it's coming from. It's exactly the same like grid power. So a kilowatt hour is a kilowatt hour, and to the degree that I'm consuming, I'm immediately consuming my own solar electricity. This is called load displacement. I'm basically my own best customer. The utility only sees electricity that crosses the meter. To the degree that I am immediately offsetting my load by consuming my own solar electricity, again, this is electricity that does not cross the meter. The utility does not see that. All of a sudden, I'm a bad customer because I'm not buying as much electricity as I used to, okay? Under net metering, there is another really beautiful thing, and that is if I am solar generating more than I'm consuming, I'm actually exporting into the grid. With net metering, we get a bidirectional meter. Bidirectional. It meters in both directions. And so for every 1 kilowatt hour that I export into the grid, I'm allowed to get 1 kilowatt hour back at a later point in time, free of charge. And the credit I get for export is good for 1 year. This is absolutely beautiful. A 12 months rolling window means I'm taking all seasonality out. I can take surplus daytime electricity into the night. I can take summer surplus electricity into the winter. I only need to look at a 12 months window in terms of how much is this load consuming per year, how much can I generate per year, and how can I get those numbers to match. We have commercial, even a small commercial account. We have also residential accounts that we have made net zero. If in 1 year you are solar generating as much as you are consuming, you are net zero. All of your consumption charge is now zero because you've made all of that electricity yourself. It's just that net metering allows you to time shift. So that's the principle. Also perfectly scalable. Here's a 10 kilowatt system we put on top of a residential building. And yes, that's the Renaissance Center in the background. We actually make our own mounting system, by the way. And this interconnect, we get shop tolerances in construction. Shop tolerances are tenths of a millimeter. Construction is 1 foot. So we get, with this interconnect system, much higher precision and works like a charm. Here is another example. This is actually one of our associates driving electric vehicle, solar thermal, solar photovoltaic, 3 arrays. He does net metering, and he has a microfit. He flew under the radar. You could not do this today because they're maxing you at 10 kilowatt combined. He basically snuck in early, and so this is how it looks like when you really fill up the roofs. So here are some images of projects that we have done in the far north. So Canada, second largest country by land mass. Between the Yukon, the Northwest Territories, and Nunavut. That's about 1/3 of the land mass of Canada. How many people do you estimate live there? 115,000. Less than the city of Waterloo, spread over 1/3 the land mass of Canada. By the way, tiny little Alaska has 700,000 people. So our Canadian Arctic is, other than Antarctica, the least populated place on Earth and spread apart wildly. And here we are. So wherever there is a dot, we have at least one solar system in operation. I am claiming southernmost on Pelee Island. We do have a solar thermal system on Pelee Island being the southernmost populated point in Canada. We have a solar photovoltaic system in Grisefjord. It's the northernmost civilian community in all of North America. Way north, Point Barrow is somewhere here, furthest north of Alaska. The Canadian Arctic islands can do a lot better. I claim a bunch of easternmost. We have 6 systems across Labrador in operation, all diesel communities. And then the Beaufort Delta, we plastered the Beaufort Delta with solar systems. We have 55 solar systems, solar photovoltaic systems, presently in operation in these remote communities. Some of them never have a road condition, not even a winter ice road. Some of these communities, in particular the ones up here, 1 ship a year. That's it. And that is if the ship can make it based on the ice conditions. Canada is such a large country, and it's mighty, mighty beautiful up there. But Mother Nature is ruthless, and you can have extreme weather conditions. I've been up there at any time of the year. I have yet to be blown off my feet, but at times it tried. So, working at temperatures below -30, -40, you need to be smart about that. And when the blizzard comes, it really shuts everything down. But when it's sunny, it can be absolutely outstandingly beautiful. And you can have optical effects that we don't know down here, like sun dogs, or 2 suns all of a sudden, or inversions. Basically, you get really interesting atmospheric conditions. Here is the northernmost solar system in North America in Grisefjord. Grisefjord has a population of about 100 to 120 people. It varies, but basically certainly less than 130 people living in Grisefjord. It's the northernmost civilian community in North America. Only Alert as a military installation is further north, and Alert is purely military. They do their own, and they're on rotation. It's not a civilian community. So this is a 10 kilowatt system, and we do go facade mount here for the reason that Grisefjord has what they call barometric fall winds, up to 300 kilometers per hour. They actually secure buildings have not been blown away. So they are known for extreme wind conditions, and going onto the facade, we're basically hugging the building, and we have the protection of the building. We have the award to go 10 times larger than this, and we will be going on the rooftop on that. We do have that award, and we will be implementing that in within the next 1.5 years, because these projects have an extremely long development lead time and one shipment a year. So here is solar generation. The further north we go, the further away from the equator, the more this 8-degree angle, the tilt angle of the rotational axis of planet Earth versus the ellipse at which we go around the sun, the more consequential that becomes. So here you see November, December, January, it is totally dark. For 10 weeks, it's completely dark. They have these caps with an LED lamp in the front, and that's how they walk around for these 10 weeks. Look at the other side. Look at summer generation. Brutal, brutally good, brutally strong. And this 10 kilowatt system made 9,760 kilowatt hours in 1 year. Voila. I mean, basically, good, bad, indifferent. What that means, about 3,000 liters of diesel have been avoided. And that is diesel in the community. Think about how well traveled that diesel is to get up there. This diesel likely didn't even come from a Canadian refinery, because we don't have many refineries. It may have come from the Gulf of Mexico, from the Texas of this world, where a lot of refining happens. Think about how many kilometers on road and then how many kilometers on ship. And with one shipment a year, you need to store for at least 1 year. What they're trying to do is to store for 2 years, because if the ship can't make it, the alternative is flying the fuel, which is extremely involved. So try to save or store fuel for 2 years. Here is the best months. 2,315 kilowatt hours with a 10 kilowatt system in 1 month. That is brutally good. You will not get that here, and you will not get that in Los Angeles or one of the warm places. Absolutely not. Here is one. Do I have that? Yeah. 105 kilowatt hours in 1 day with a 10 kilowatt system. That is 10.5 sun hours. Have you heard the term sun hour? Have you been introduced to that? Well, I can tell you that in Windsor, our average is 4 sun hours per day over the year. The peak summer, we're at 6 to 6.5. Here, I'm showing you over 10. You will never, ever get that down here. Here you see a couple of things. This is 24-hour generation. Will we ever have 24-hour solar generation here? Hell no. Here we do. It is low because this is on the south facade. The sun is on the north side of the building, so I'm only getting indirect light. I'm not getting direct light. But you can see also here, so I'm starting to meet the load here, and I'm meeting the load until here. And it looks like this is your load curve. They must have had an afternoon or evening event, and then they shut it down again. So for 8 hours, this solar system has met 100% of the load. In this period, it has been exporting into the grid for credit. If I am allowed to do larger size, I can do more. Solar generation is proportional to my array sizing. The utility is putting limitations on that. The utility makes the rules, they interpret the rules, and they are a choice of one. So I cannot do as much as I would like to, but sure, we could do a hell of a lot more. So just let us do what we can do, and we will move closer and closer to meeting more load over larger time periods. Here is the first commercial independent power producer solar project we did. The very first one in Nunavut. We did that 3 years ago. I have 2 years worth of data. And this is 110 kilowatt. So this is 1 order of magnitude larger than what the utility has allowed us to date. Today, after we successfully realized this 2 years ago, I have 4 such awards, and all of them in the northernmost. I have made argument, and apparently somebody was listening, I made argument that a solar kilowatt hour in the far north is so much more valuable than a solar kilowatt hour in the south because of the need of transporting and storing the diesel up there. So let me do the northernmost, and these are the awards we have. I don't know anyone else who's doing this stuff up there. So we basically have developed a track record second to none, but believe me also, it's extremely challenging. The logistical challenges, the local challenges, like everything around, I'm living the adventure of my life. So here's another example. We actually design and build our own mounting system, so we can do special work. Here we're using so-called S5 clamps, no penetration. We actually latch onto the standing seam, and then we put our rails down, our mounting system down, and in this particular case, we have a modest angle. Again, here we're talking very high wind loads, and also the wind will pile up the snow. So in winter, all the valleys will be completely filled, and it's a kind of snow that isn't snow anymore, it's ice. There are 30 different conditions of ice you can have, and when it is as cold as it is, it's more ice and snow than anything else. And then you also get into the powdery snow that will blow all over the place. So here, very restricted electrical room. We usually do not like stacking inverters on top of each other. We had no choice here because it was so limited. So you see here 6 inverters stacked up, and they all need to be electrically connected, et cetera, et cetera. So to date, 55 solar systems in operation in northern diesel communities. And we have, in last year, generated over 1.3 million kilowatt hours. And that means over 370,000 liters of diesel have been avoided. And again, this is diesel in the community. So you need to add to that for the energy spent to bring the diesel there. I usually would add maybe 20 to 25%, but I cannot quantify the logistics because they're different for every community. Challenging they are for every community. And so here's nearly 1 million kilogram of carbon dioxide avoided by avoiding using this diesel. We do community engagement. So here, for example, we are doing a hands-on show in terms of solar photovoltaic. I claim the northernmost solar cooking in North America. I bring in these solar cookers, concentrating solar cookers from Germany, and then we donate them to the community, and we use it to demonstrate the power of the sun. So here I was making lunch. And so the solar cooker will stay behind. How many people do you know who have done solar cooking in the Arctic? Well, how many people do you know who have ridden the bicycle on Ellesmere Island? So I do allow myself to be playful at times. And when we ship these large crates with solar material, and there's still room in the crate, I throw in a bicycle, okay? And then I ride the bicycle in the community, and then the bicycle will be donated. So northernmost community, one morning, the sun was not yet up. I take my bicycle and I go north of the community. I wanted to make sure for sure that I'm the northernmost, okay? I'm not aware of Alert having bicycles, okay? That's military. They very unlikely have bicycles. So I was north on the tundra with this bicycle, and I said, okay, this is a moment. Now you are the northernmost bicyclist, and I can claim that probably for the rest of my life. I have yet to do this on a glacier, but if you go to our website and you go to news and you scroll down, you will see somebody riding the bicycle on the frozen Arctic Ocean north of Tuktoyaktuk. Guess who that was? Okay, video, please. We did not pay for this video. We are featured in it, but we did not pay for it. Someone donated money to a non-for-profit organization, and they chose us and our project, and they chose the community, just as a disclaimer. With audio, please.
There's a thought of renewable energy. It makes me feel a lot better knowing that we won't have to rely on diesel just because of its impact on the environment, but also it's just instilled in us to respect the land. We have the capacity to understand and accept things that have happened, but also to look forward and to change what we know could be renewed.
Summer is like my favorite season because I get to use my clothesline. It's like it's just one less thing to use in my house, so my hydro bill won't be so high. That's how I hang my clothes, my laundry every day for my girls to save on power.
I believe in clean energy because we got global warming happening right now, right? It's all from diesel and gas. Clean energy doesn't make excess heat, though. You got the wind power, you got the solar power. They don't make heat; they just make energy. I'd like to see that kind of project go ahead.
So here is a beautiful Labrador, and here is the community of Nain, here is Hopedale, here is Postville, here is Makobik, and here is Rigolet. All of this area here is the Nunatsiavut territory. All 5 Nunatsiavut communities are powered by diesel, and diesel exclusively prior to receiving the solar systems of ours. My name is Klaus Doring, and I'm the president of Green Sun Rising, Inc., a local solar company. 3.5 kilowatt hours of clean solar electricity mean 1 liter of diesel less going through the local diesel power plant. So in the example of Nain, it's a 24 kilowatt hour AC solar photovoltaic system, which will be providing approximately 25,000 kilowatt hours per year. If you divide that by 3.5, you're somewhere at approximately 8,500 liters of diesel per year that do not need to be consumed in the local diesel power plant. Now, this is diesel avoided in the community. How much energy is being spent to get the diesel to the community? The diesel being used in Canadian remote diesel communities is extremely well traveled. You can easily add 20-25% to my number just for the effort, cost, and energy of bringing the diesel fuel to the respective community.
Within my life, the power has been going like on and off all throughout. But I just know like how it impacts the environment and how like that makes me uncomfortable because our land is so beautiful and we don't want, when I say we, I mean like my community and most Inuit in general don't want anything to further impact the environment. I was taught to always take only what I need from the land and just be respectful. So in terms of renewable energy, it aligns more with that value. It just makes sense.
The way we look at nature is different from, I hear people say they'll use the land, they'll rig the land, but if you do that, then you have nothing. You have to work in sort of like cooperation with the land instead of tearing it apart. And if you take something, you give it time to replenish.
The beauty of solar photovoltaic electricity is that it happens just automatically. To the degree that sunshine comes in, free electricity comes out and is available right there. Perfectly quiet. No moving parts. No vibrations. No emissions. Now every Nunatsiavut community has an operating solar system. The sun is the most reliable source of energy. The sun will rise every morning. I may have clouds in between. I may have seasons. I may not be able to exactly predict tomorrow's weather. However, I can predict exactly when that sun rises and when that sun sets, and the motion of the sun over the horizon over the whole year. This is one small step towards less dependence and more self-resilience.
Being independent allows us to live our lives the way we want to and not the way we're told to live, which is a huge thing. And like, as you know, in the past, we haven't had that right.
Being independent, I think, will give us pride. We can take care of ourselves, make us independent from the oil company. Oil and gas cost so much these days. With clean energy, we won't use so much diesel. So less diesel we burn, the better off we are. For the world anyhow.
Ultimately, everything comes down to people. You can make changes in your lifestyle choices. You can become an agent of change. You can become part of the solution, moving towards a solution. We need to embrace sustainability and getting to self-reliance. You can make your own contribution and ultimately become a part of the solution and stop being part of the problem. You are in charge of your own choices.
If we're on the land and it's polluted or destroyed, it's not healing at all. It's the complete opposite, which is what we're trying to work against. A lot of what we do is just being proud of like who we are and what our culture is about and what our traditions are. Renewable energy would allow us to do that. Even though a lot of things have changed, our culture is still at our core no matter what it is.
And now, hopefully, lots of questions.
Okay, thank you very much, Los, for that very interesting presentation. So I open the floor for questions. Oh, I should be using a microphone, though. Again, thank you for your presentation. Very interesting. I appreciate it. Thank you for being here. I know that it's a long drive for you. Now I open the floor for questions from the audience. Yep, go ahead, Dario. Yeah, you need the microphone. There's another microphone that can go around.
Thank you so much. Hi. Well, first of all, thank you so much for this speak note. This was really interesting, especially looking around all the projects that you have in the Arctic. It's really exciting actually to hear about it. I have so many questions. I probably can just talk to you later the presentation, so I don't want to take all the time. I have one specifically, or two. The first one is when you mentioned the figure of the 24 hours that you met the community loads by almost 8 hours, you have this excess of energy to export. To where do you export that energy? Because I assume that there is no grid in that, so that will be the case without the grid.
This particular data I shared is for one particular account. It's not for the whole community.
Okay.
So the electricity will go into the local microgrid, and because electricity is lazy, it flows the path of least resistance, so the next door consumer will receive that excess electricity until all of it is consumed. So the flow of electricity is really simple. A conductor is a conductor, okay? And the cross-section of the conductor determines the resistance, and the wire losses are driven by the length of the conductor. So the electricity that we send into the microgrid will meet the load next door until it is completely used up. If it was on a community scale, we would need storage.
Yeah.
Now, if we want to avoid storage and we are reaching limits, there is one more thing we can do. We have a few technical tricks up our sleeve. We can derate a solar photovoltaic system at no cost. I cannot derate solar thermal. With solar thermal, I need to have the energy being removed, even if I have to dump it, but I have to remove it. Solar photovoltaic is different. There is a so-called IV curve. Basically, current over voltage, and I can move my point at which I take the DC power at any point of the IV curve. And I can beautifully and within milliseconds derate the solar system. What we can do is put CTs onto the service entry. That's what we have done here, by the way. We're sharing smart meter technology. So I put CTs onto the service entry, and I monitor the flow in, out. I have my monitoring system for my solar generation, and I take both of this data into one platform, and now I have both. I have my grid interface, and I have my solar generation, and now I know exactly when I consume how much and from where does it come from. So on a community scale, we would also have more of the averaging of the numbers, because if you have many consumers, their timing will be different, and over a large number, that does some averaging. These microgrids are relatively small, and you're not getting the benefit of that averaging, which is why today the utility are severely restricting us. We will work on opening that up. Time is our friend, and large-scale storage will be our friend as well. Right now, we're still doing the low-hanging fruit, because until every building has a net metering project, I have lots and lots and lots to do.
Yeah, no, that sounds amazing. And the second question is more regarding the social impact that you have on those communities. I will assume that also the solar panels or the solar arrays, they need maintenance. So in the case of Sunrising, like you will do like the maintenance by yourself, or you will train like people from the communities where you like build those arrays, like just for them just to be independent, as was part of the video that I was mentioning about.
Yeah. We typically have local people working with us shoulder to shoulder. We typically leave spares behind. So at least on a mechanical side, these people will be able to do simple maintenance. A solar photovoltaic system is nearly maintenance-free. As long as I have internet, I have monitoring, and I can look into the brain of the system. If it is something electric, then an electrician has to be brought in. And the electrician may not reside in this community, but there are electricians in Nunatsiavut available to do such work. So in terms of benefit, in most cases, it is the municipality that owns the solar system. They receive the grant funding to pay for it. They operate the building. They pay the operational cost. They save. So all of the solar generation for municipality-owned buildings generate savings, which frees up money in the municipal budget, which now becomes available to other things for the community. The community does understand that they own and operate these solar systems, and that they, through this mechanism of saving in their annual budget, actually financially benefit as well. The reason that most of our clients are municipalities is simply that they pay the highest tariff, the highest rate, and they have access to up to 100% grant funding, and there are different funding ways available to municipalities to upgrade their own buildings.
Yeah, thank you for that. I have a follow-up question. Is regarding, we did a lot of studies funded by WWF and in the impact of these communities and Hydro One, more communities, and funding from OCI. And when we were looking at these issues, we were interested in the solutions, the same thing, that we demonstrated that what you're saying, it was what's actually taking place. Something that we noticed though in our studies, and we are demonstrating otherwise, is that once you move further north, solar wasn't as relevant as wind. However, you are showing with all these deployments that solar is part of the solution. Can you comment that, make that contrast with wind and solar?
I don't do wind. I'm a friend of wind energy because I'm a friend of renewable energy. I actually operate a 1 kilowatt wind turbine at my renewable energy technology center, and I'm observing it, taking it apart, okay? Basically, it's in the process of failing. I like wind, no question. Here is the fundamental problem. the wind industry and the serious players have developed bigger and bigger and bigger and bigger. With every 1 meter in length increase of your blade, your swept area grows by the square. So larger, higher is what the wind industry is moving to. Some of these offshore turbines are incredibly large. Wind is very intermittent. When the wind is good, it is brutally good. It can overwhelm the system of the community. So a lot of these communities up there are small. Can you put a 1 megawatt wind turbine into a community with 200 people? You'd be completely overwhelming their system if wind is good. So there is one more problem with wind way up north. A wind turbine has moving parts. It will need some level of maintenance, and this is highly, highly specialized. You're working at a nacelle height of 100 or 120 meters. That's not for your average person. And you need 2 people for security reasons, and they need to be highly trained. If you have in one remote community, 1 wind turbine, and the next community is 500 kilometers away, how long can you hold 1 wind turbine technician? He's going to be gone because he's being bored to death. You cannot have a maintenance team for 1 or 2 wind turbines. You need to fly them in. And now you look at how many days do you need to fly a person in, and that will be downtime for the turbine. I'm only aware of 1 successful wind project in the Canadian North, and that's the Raglan mine. And Tuglik Energy did that system, the Raglan mine, and they put in 2-3 megawatt turbines. And I talked to them. I know the people. They did a fine job. A mine is a massive, energy-hungry operation, and they are saving by operating these wind turbines. They are actually looking at adding to that as well. Here's a problem with a mine. A mine is depleting. So a mine has a limited time, limited lifetime. And then the mine is basically depleted and needs to be moved. How do you move a wind turbine? So basically, I'm a friend of wind. I want us to do as much wind as we possibly can. I do not believe that large wind is really suitable way up north. I do actually see a business case, and I have mentioned that numerous times. I see a business case of a company developing the most robust 10 kilowatt wind turbine that you can imagine. And then you do 100 of those. They have the land. The land is there, okay? And you need a 10 kilowatt wind turbine that has a tower, a tilting tower, and 2 guys and a truck can put it up and can replace it. That's what you have there. You have 2 guys and a truck, and they are very mechanically inclined. And if you put a wind park in there of 100, you give them 20 replacement nacelles. And when one breaks, 2 guys and a truck go out, they lower the tower, they mechanically replace it, they bring it back up, and once a year they ship the damaged parts down south for repair and bring them back up. That's my recommendation. So small wind, extremely robust, and such that 2 guys and a truck can maintain, can replace them, and that's how I recommend.
Very, very good point. The problem, I guess, is that you will have to design special systems for these communities, and the business case is hard to make. Whereas in solar, I guess you have the same thing you deploy here, you can deploy there with some variations, but basically makes sense in from the big pictures. So anyway, I commend your work in this area because it's basically proving that solar is part of the solution, and that's very important. Now, a follow-up with this is, you show some cases here where you have extra solar, right? You have all these additional solar, which basically more than what you expect. Now, what is the business case and what is happening with battery deployment in these communities? How is that evolving? Is this an option? Is it allowed? How is this working out?
Yeah, I did.
Batteries, adding batteries to these systems. Battery energy storage?
Oh, battery. Okay, battery. Battery storage will definitely come. There are already first systems that have been done. with significant government funding, and there will be more. At this point in time, I see the most cost-effective way of doing the net metering because I don't need the batteries. Batteries is chemistry. They not only cost money, you have turnaround losses, and they do age. They also have problematic materials inside. So if you ship a battery into a remote community, you should, after 10 or 15 years, bring it back. It needs to go into recycling. It cannot stay in the community because otherwise you start polluting the land. So battery technology, I do believe, will come. It will benefit from these mega battery factories that are coming. And who knows what chemistry we will have in 5 or 10 years, because there's an awful lot of good researchers working on battery chemistry. I'm basically at the bottom of a Pareto. There are all these net metering opportunities, which are the most cost-effective. So let's harvest that first, and then at a later point in time, we can add various things. To the point of solar feasibility, I'm claiming that the International Space Station is purely powered by solar electricity since, 14 years, 15 years? I claim the Mars rover is an electric vehicle, solar energy powered, okay? And those two examples are operating under the worst conditions you could imagine. So if we think it gets cold in the Arctic, well, look out in space, okay? So I do believe that photovoltaic has shown, including in satellites, that it can operate in the harshest conditions imaginable. And yes, we have now 10 years worth of data from systems up north. And when we go to a community where we already have a solar system, we go and check it out. And I weekly look at the monitoring. The biggest challenge there is a loss of internet. That is unfortunately frequently happening. And if the internet connection is lost, then I don't see the data, then I'm blind.
Thank you very much. Any other questions? Yep, go ahead.
Thank you for the excellent presentation. So you mentioned you operate in the north, so I have a two-part question. The first one is, during the winter season, when the sun isn't shining as much, how much solar energy are you producing? And a follow-up to that is, when it does snow a lot, and so the snow is on the solar panels, and then the following day it's sunny, do you remove the snow? Does it melt off? How does that work?
On question one, solar photovoltaic works very proportional. Photons in, electrons out. Many photons in, many electrons out. No photons in, no electrons out. So the solar photovoltaic generation is extremely proportional to the solar resource availability. That answers the first question. Second point is, we do not want people to go on the roof and to scrape off the ice. You couldn't even do that up there because it's so hard and so frozen that we recommend let Mother Nature take care of it. You get snow and ice when you have much less solar resource availability anyway, so you don't have much to lose. We use what is called black line modules, basically modules that are black. I have personally experienced in Inuvik in March, at an ambient temperature of minus 30 degrees Celsius, the front of the module melting and completely self-clearing. So if you use black line, and if these photons have an opportunity to reach the surface, they are turned partially into heat. I mentioned the 20% efficiency. Well, what that means is 80% inefficiency, and where does that inefficiency energy go to? Heat. So basically, black line will heat itself, which helps to self-clear under winter conditions, but only to the point that solar resource is actually available.
So how long does that take? And let's say you're not able to clean it off, so you just depend on diesel?
If you are not able to clean it off, then you do what you have been doing for the last 40 years. You rely on diesel, yes.
Well, thank you. I think we're running out of time, but I would like to see if there are any questions online. I notice a comment there.
Who can see your messages?
Okay, so I guess there isn't any. Pardon me? Or just thank you. Okay, well, thank you very much, Klaus. I appreciate the time and effort to come here and make this very interesting presentation. Very much relevant to the work we're doing in WISE. I mentioned that we're starting a project with northern communities in Inuvik, and so we'll be interacting with you if you don't mind. I appreciate it. Thank you very much again. Thanks.
Thanks for the attention and interest. I'll make a prediction. Solar energy will become mandatory in your professional life by code. Thank you.